Welcome back, everybody. In this video, we're going to introduce you to the idea of using binary numbers to send messages across a network, like the internet, your cell phone, whatever device it is. It's going to assume you know some basic binary and just the idea that it's zeros and ones, and that's about all you have to know for this point. So let's take a peek here. You'll see here I've got my ASCII chart pulled up. This is going to help me determine the binary for the symbol. So as you can see here, if I wanted to send the symbol 6, I've got my binary code ready to go there. I'm going to be using capital letters for an example message. So you can see if I want to send the letter A, I can just send that binary right there if I wanted to. Okay, now that's assuming you want to use the ASCII table. Now remember, if you want, your name's Bob, you can make the Bob table and invent your whole table with what the ones and zeros mean. But I may as well use this one since it already exists and it makes it easy for us. So let's take a look at an example message and just talk about some of the concepts involved with using binary to send messages. Here I'm going to send a really simple message. ABC 123. You'll see here I've used the ASCII table and I figured out that that is the letter A. So you can see here the letter A is that right there, which happens to be the number 65. You'll see our decimal equivalent. And then I've grabbed the letter B, the letter C, the symbol 1. Now it's really important for my rule set that I'm going to use for this particular message. This isn't the binary for the number 1. This is the ASCII code binary for 1. So for example, when I want to send the number 1, it's just a symbol like any other symbol on your keyboard, and that's the code. It's code 49. So I actually send 49 over because somebody's determined that's what they've assigned the 1 to in the ASCII chart. I do similar for 1, 2, 3, and they end up getting this as my message. Now, keep in mind that when you actually do this, the ones and zeros aren't actually sent with spaces between them. They're actually sent like this. And I have a rule. And my rule when communicating with the other device would be this. Whoever receives this big long string of ones and zeros is going to read them in groups of 8. So I would tell them, read 8, use the ASCII table, figure out the symbol. So they would read 8, take that, convert it to a number, and that would be the number 65. And then look on the ASCII table for 65, which is A. Now you could also look for this, right? That's going to be faster for you guys, not doing the conversion to the 65, right? Since we have this table right here. But a computer would convert it to 65 and then look on the table and see that it's A. And then what do? The rule is read the next 8 and then get the B, read the next 8, get the C, and you go down the line. Now it's really important to note here that my rule, read 8, is important because if you look here, originally this was split up like this. It's going to take me a sec here. My vision's going a little blurry. There we go. It was sort of split up like that with the spaces between. Notice this extra 0. Some people say, why send the extra 0? If I want to send the number 65, I only need that right there. Well, this extra 0 is called padding. And the padding, what it does is it makes this group of bits, the ones and zeros, instead of being 7 long, it pads it and makes it 8 long. You'll notice here when I sent the numbers, there were actually 2 zeros in front. Some people say, well, skip the 2 zeros. Just write the numbers you need, right, to get the value. But if you actually think about it, if you didn't send those extra zeros to make every group a group of 8, okay, you removed the padding, then what happens is you have this. And of course, this now gets pretty confusing. How many do I read here? Do I read 6? Do I read 8? Do I read 4? No idea. There has to be a rule system that you stick to. And my rule system was read in groups of 8. That way, if I have 8 ones and zeros, it works. If I have 6 ones and zeros, it still works. Whoops, here's the 6. If I have 6 ones and zeros, it still works because I padded up with an extra 2 zeros to make it a group of 8. And if you have 7 of them, you pad it up to a group of 8. It's always going to be a group of 8. If I gave you this here and I said, guess what it is? If you try reading groups of 8, this doesn't work because I've removed those extra zeros for padding. And if you don't know to read in groups of 8 or 6 or 7 or 5, it's pretty well impossible to determine where your letters or characters start and where they stop. So this is a really important idea with your protocols. You have to have some set size that you're reading in. Now that size can change whenever you want, but it has to be in your rule set, right? And this simple rule, read in groups of 8. Check this out here, just to show you don't always have to read in a group of 8. Let's say I'm sending some data and it has something to do, people voting yes or no, do they want to go out on Friday night to the party? Now, instead of sending the word yes or no across the network, people come up with a little rule. They say, you know what? Send a 1 for yes, send a 0 for no. One person comes up with this idea. I'll send 0, 1 for yes, 0, 0 for no. So you'll see here if these were the votes in order, this ends up being the zeros and the ones. And if we take the spaces away, that's the big chunk of data that gets sent over the network. As long as the person on the other end knows, hey, when that data comes in, you read 2 bits at a time, then it's going to work. They'll read 2. Oh, it's a 1. That's a yes. They read 2. That's binary 0. That's a no. 2. That's a 0. That's no. 2. That's a 0. That's no. As long as they follow your rule system, you're all good. Some other student says, why send the extra padded 0 there? All we really need is 1 or 0. So they decide to do this. And you know what? That's what it sends. It's half the amount of data. And that still works totally fine as long as the person on the other end knows that the rules are read 1 at a time. Now, if all that makes sense to you, how all these 1s and 0s can represent like text and numbers and the little rule set, you're going to like this one. Maybe you play network games, maybe you don't. Well, either way, you're going to learn a little bit here about how the stuff is sent across the network. Now, just let me make this fit on the screen. There we go. And check this out. When people are playing video games, there's a lot of data being sent back and forth, you know, between the computers that are playing online. Here's a really simple example. One thing we want to know about a player is their X position, okay, where they are in the world. It's sort of like a math grid. And this value could be 0 to 100. We also need to know their Y position. We also need to know how many lives they have currently. So 0 to 9, that would be the most they could have, would be 9. And whether or not they're currently trying to fire. Now that's just a yes or no. So that just has to be 0, not firing, or 1, yes, they're trying to fire. Now, here's my system, my rule set that I've invented to send the data over that'll tell you about a player. Since the largest this value could be would be 100, I'm going to actually use the binary to make it so it actually counts up to 100. Now to count up to 100, the number of bits that I need, well, I need the 1s, the 2s, the 4s, the 8s, the 16s, the 32s, and the 64s. If I have all those bits provided, I can count up to 100 and past, okay? But as long as I can get to 100, I'm going to be good. This is 7 bits, okay, that I'm going to need. For the Y position, it's the same thing. I need to count to 100. That's going to be 7 bits. The lives, 0 to 9. I have to be able to count as high as 9. To do that, I need the 1s, the 2s, the 4s, and the 8s. That would actually let me count up to, I think, 15. But that'll do. Okay, I can get to 9 for sure. That's only 4 bits. And whether they're firing or not, only 1 bit is needed because that's just a yes or a no bit, right? 0 for not firing, 1 for firing. Let's take a look now at how I could send the data for one player at that given second, where they are, how many lives they have, and whether they're firing. So let's say they're at position 40. What I've done is I'm not using the ASCII table. I'm not sending a 4 and sending a 0. My rule that I've just invented is going to be do the number 40 in binary. So if you have to use the calculator or whatever, you get it, and it ends up being this, 101000, right? 132, 18, nothing else. Now, because my rule was 7 bits, like if I had a value of 100, I'd have to be using all 7. I would have to be using that. So what I do is I say, well, I better pad it up. Okay, so even if my number doesn't need all 7 bits, always make it 7 bits. That's the rule here. So 7 bits. I send the 40. I do the same thing for 65, which I've done incorrectly here. 0, 1. I think that's right. So there's a 1. No, I had it right before. I had a 64 and a 1. And so that ends up being 65. And that is 7 long. That's perfect. And 3 lives. So a 1 and a 2 gives you 3. And this one had to be 4 bits because I could be counting as high as 9. So pad it up and give it the extra 2 zeros. And there's my firing. 1 means, means yes, I'm trying to fire currently. So that's the data you send. I send that data. Remember, there's never spaces when you send data, so it ends up being that is the actual transmission. And whoever gets this, because they've got the same program following the same rules, they're just going to follow the rules. Read the first 7. There it is. Convert it to a number, 65. Or sorry, 40. So they got the X position. Read the next 7. Convert it to a number, 65. They got the Y position. Read the next 4 numbers. Convert it to a number, 3. They know 3 lives. And the last one, read 1. It's a 1. Yes, they're firing. Now that computer can put the player there, make them fire, and show that they have 3 lives. So that's sort of the basics. This isn't like a system that I've stolen off the internet or anything, but it's probably one that's very commonly used, or something like this is used. The idea of padding, the idea of coming up with a rule set, and as long as the other side is following the same rules, you are all good to go. It's really important to remember here, your rules, your protocol. Any rule system's going to work as long as it works. And I know you go, what? That doesn't really make sense. But if you've thought about it, the rule system works. You can test it out, write some 1s and 0s, and see if you break it down on the other end, do you get your original message back? And that's where we're going to be headed with this. We're going to be making our own protocols to do a few tasks. So hopefully all 3 of these examples made a little sense to you. Good luck, and have fun with your own protocols that you make.